what's up people? Good evening, how's it going to all of you all over the world? I hope you're having a good, what the hell day is it? What even day is it today? It's Tuesday. I hope you're having a good Tuesday evening or afternoon, whatever time it is in the world where you are. So today we're going to be looking at Sundown amplifier, which is in a nice box. They don't usually come to me in boxes like this, so this is quite cool. So this is a Sundown SAZ-1500D. It looks in pretty good condition as well. Get this bad boy out of here. Okay. I always like how the Sundown amps look. They have a nice clean kind of finish on them. It's yeah, it looks pretty cool up in here. Nice matte black with the brushed aluminium centerpiece, Sundown logos, and then you've got the amp model logos. You've got one the correct way around and one upside down as well, in case you're gonna swap the amplifier around. Now, some of you may not have necessarily realized, but if you have to mount this amp upside down, you can actually remove these two bolts and flip this centerpiece upside down so that the Sundown audio logo is the correct way around in your system. So pretty cool. Always a nice build quality in these things. So let's open this baby up and see what the issue is here. How's it going? Yes, very well, thank you. Very well indeed. I'm glad you like the new intro thing. It just makes it's just a bit nicer than just me sitting there, you know, waiting for the stream to pick up, and it means that the more people get to see the very start of the amplifier repair as well. I mean, there's only a handful of viewers just now, so it doesn't make a huge amount of difference. But you know, every little helps. Why not? Okay, lovely stuff. So this is actually quite an old circuit design. Where are we? So here we have, this is a Class D amplifier, of course, and the driver board in this is actually very similar to a lot of driver boards that you'll find on the likes of Hyphonics and even cheap shitty amplifiers like Lanzar Vibe. Phoenix Gold implement this driver board as well. So it's a discrete transistor Class D drive circuit with the AG and the DK transistors there, and you got a 072C chip and a LM211 chip, and that's what does the generation of the Class D PWM. And then on the outputs, I think from memory, these amplifiers have, I think these have PNP and NPN. I could be wrong. Let me just remind myself. So we've got IRF 640s, and we might have IRF 9640s as well. Yes, we do. I was right. So we've got IRF 640 and IRF 9640s. This is a much older style of amplifier that uses N-channel and P-channel MOSFETs together to create the audio wave. So let's find out then why this amplifier has come to visit me. What is the problem here? Why is it not working? Before we even go to put some power into this, we can first of all do the preliminary checks with the multimeter on diode beep setting, and we want to make sure that there are no obvious short circuits across the power supply or across the outputs. Oops. So we want to first of all take our multimeter probes and check that there's no continuity between the power supply, the two things here. Looks promising, so there's no continuity there. One way round we have discharging the caps backwards, one way round we have infinite resistance, which means the caps are somewhat charged, so we won't likely have a short on the power supply transistors. We don't, so that's a good start. Power supply is intact. Let's check out the output section. So we're just probing between legs 1 and 3, then 1 and 2, then 2 and 3 on the output section, and we should be seeing numbers around about here. This shows that the MOSFET is in good condition. It's not shorted between legs 1 and 3, 1 and 2, or 2 and 3. Okay, that's good for that side. And check out this side. Okay, this side seems to be alright as well. So this could be one of those strange occurrences where somebody sends me an amplifier that actually is perfectly functional. So the next thing to do, if we've done the very basic check of making sure that all of the MOSFETs are not shorted, we don't need to check every single MOSFET, because if there was a MOSFET that was shorted in the same bank as the ones that we tested, it would show up on the multimeter as a very low value. So the fact that that didn't happen means that there are unlikely to be any shorted MOSFETs on this amplifier. So now that we know that that's the case, we're very safe to go ahead and plug in our power supply, turn it on, and see whether it works or not. How is everybody doing? And how's the stream quality looking? Is it okay? I've messed around with the settings a little bit, and so hopefully the audio and the stream quality is okay for you guys. Okay, so let's go and fire this baby up. I'm going to turn my power supply here. We're going to go for about 10 volts worth of input, and let's give it about 4 amps worth of current supply. Take our oscilloscope probe here, check that we have our 10 volts on the drain of the power supply MOSFET, which we do. Hit the remote pedal and it should start to come to life. There we go, it starts coming on. So now we're just going to make sure that we have the correct rails. So if we have a look here, we should have negative rail, and then nothing on the middle. And on the 9640 you should have positive rail, and nothing on the middle. On the other side should be the same. Should have positive rail, nothing in the middle. Negative rail, nothing in the middle. Alright, perfect. So let's go ahead and probe this fully and turn her on. Okay, so it's not perfect. There are what looks like some issues here, and there's some quite heavy current draw going on. As you saw there on the power supply, I don't know how well you could see that, but this thing was actually drawing some pretty hefty current just then. Wow, okay, so that time it came on, but something is shorted, something is heating up on the amplifier. This amp should draw nowhere near that amount of current when this thing goes to turn on. Can you see that there on the power supply? Look at that, 5.3 amps, and it's therefore reducing the voltage down to 6 volts to get this thing to actually, regulate at 6 amps. So something is not happy. So the fact that the output section actually worked just then, so we probed the drain of the low side MOSFETs. So let's go ahead and probe all of those and see what happens. So we want the high side now, that was also a square wave, so that seems to be okay. The low side of the other side, that also becomes a square wave, and the drain of the high side on this side, okay, that also seems to be alright. So the issue could be a shorted inductor, because we have extensive current draw, but we do have a switching wave on the power supply and on the output section. It could be a shorted or kind of rubbing, shorting inductor core on the top here, because we do actually have good drive. So what I'm going to do is I'm actually going to, because this amplifier is drawing a lot of current, one of the things I can do is I can take my thermal imaging camera here, and when the amplifier draws current, that current is going to be going somewhere, and it's going to be causing heat to be somewhere on the amp. So we should be able to see whatever's dumping the current should be getting hot. So if we take a look here with our thermal imaging camera, I'm going to turn the amp back on. And you can see just up there, just tiny on the top on the screen there, you can see the amount of current draw there. And you can see it hopefully on my screen here. Okay, so what gets hot? Okay, it looks like the FETs on this side get hot. So I'm going to try and zoom in here just with my head cam to the camera here. Now the camera looks much better in real life, but you can see there are some hot spots starting to appear on this side of the amplifier by the MOSFETs. Now they're still clamped down to the heatsink, so that will be dissipating the heat. So just to emphasize that issue, what I'm going to do is I'm going to remove the MOSFET clamps to the heatsink so that FETs can't get rid of their heat, and then we should see them heat up much quicker. I do need to be careful doing this because there's obviously a short somewhere, so these FETs will be getting really hot really quickly if they're not clamped to the heatsink. So what I need to do is I need to turn the current down on my power supply a little bit from 5 amps. I'm going to take it down to just a tad. I need enough current that the amplifier starts with its Class D switching, but not so much that the FETs explode the second that they get some power. So let's remove all of the FETs from the heatsink just now. Good evening to Seth. How's it going, buddy? Good to see you on the stream. Speaker Freak, wouldn't be the first time someone has sent you an amp thinking it's broken. I totally didn't do that myself. Oh yeah, Speaker Freak sent me a JBL amp that seems to work fine. So, but however, we are going to be doing some upgrades to that amp, so it's not a complete waste that he sent that in. Whoop. Good evening, Giant. Good to see you on the stream, pal. Hopefully the Steg should arrive pretty soon. So if any of you were following my live streams a while ago, I was repairing a Steg amplifier for Giant. I actually managed to work out what the issue was. If anybody's watching the stream just now and was following the repair of the Steg, I did a few videos, a few live streams of that where we were having some really big headaches and would like some information on what caused that, then let me know and I'll talk you through what that was, what the issue was in the end. Aaron Brewer, hey Sam, happy to see new videos again. Thank you, buddy, no worries, I'm happy to be doing them. So now that we have our MOSFETs removed from the heatsink, let's just very quickly, and I don't want to do this for too long because it is quite dangerous, I'm going to power it back up again and these FETs should get really hot really quick. Okay, so there was a fair bit. Oh, yeah, here we go. Yeah, so there's a couple of FETs here, and that was on for about 5 seconds, I'd say. And there's a couple of FETs there that are getting to 35 degrees within 5 seconds. Only 2 of those FETs, by the looks of things, are actually getting hot. We've got 2 here and 1 here. But it is all in the same kind of bank. So I am wondering, I have an inkling that this inductor core might be shorting to itself. Either that or there is a drive fault on this bank of MOSFETs or something along those lines. So the first thing that we're going to do in seeing what the issue is here is have a play around with this inductor and see whether we can actually see any telltale signs of shorting on the inductor. I'm going to take you to my zoom in cam for this. I'm going to actually try and zoom in on this inductor so you can see what I'm doing. Okay. So that's this one here, right? So usually these things will short out to the core or to other bits of copper wire that they are touching. So if we wiggle this around a little bit, now this is obviously glued, so if we pull that top one away, this top one's the most common one to be shorting by the looks of things. Actually, I think I've been inside this amp before. This looks like some CA glue of mine. This looks like the DD. Oh no, it's not. It's Bounty. That's not my CA glue. So I haven't been in this amp before. It just looks like one of the glue that I use. So I'm actually just gonna move this away from touching there. And now that I've actually moved it around a bit, I'm actually going to power this back up again and see whether it still draws excessive current, because I might have wiggled it so it's now not shorting out anymore. Okay, no, so it's still drawing current. So another thing I'm going to do is now I'm going to actually start wiggling it around with my hand whilst the amplifier is powered up. And I probably should give you this view here so you can see the current draw on the thing there. Okay, now that doesn't seem to be changing the current draw at all as I'm holding it on. So this inductor is possibly fine, and it could be a drive issue or just bad MOSFETs on here. P183J. We do have different batches of FETs in here, but these do look factory. They get pretty hot as you turn it on. But it's only the ones on this side that get hot. Interesting. Okay. It could also be this inductor that's shorting. It's not always the one that's on the bit that's getting hot. It could be the other one that's shorting out and causing the other side to go into overdrive. So let's turn the amp on once more. Let's wiggle this inductor around. Nope, it doesn't seem to be that one either. Okay, so there's other issues going on. So let's turn our attention back to our oscilloscope probes here. And let's compare the drive wave then to these FETs. Now, because these are clearly getting very hot within a few seconds, I'm actually going to screw them back down to the heatsink so that we can have the amplifier turned on for a longer period of time whilst we are probing things to try and work out what's going on here. Brandon Mar says, good evening sir, missed your streams. Oh, thank you. Well, hopefully you should be seeing quite a lot more of them going forward now that I'm back from the States. The FETs on the other side are not heating up, no. So the FETs are only heating up on one side. We have two FETs that are getting very hot and one FET which is getting somewhat hot. And it's only on this side. So the thing with that can be a issue with the whole bank, but obviously FETs will have different tolerances between themselves, and so it will be the weaker ones that get hot first, or the ones with the lowest resistance that get hot first. It won't always necessarily be they all get hot at the same time because they have different things. So the fault with the Steg was not yes. The fault with the Steg was actually bad drive ICs. So if you remember from the live streams of the Steg amplifier, we would lose the top half of the sine wave under load, and it would get very, very hot on the high side drive. So I tried replacing some parts on the driver board, thinking that it was to do with the PWM generation. That didn't work. I tried changing the output FETs. That didn't work. And we did a few other tests and bits and pieces. But the thing that fixed it was changing the drive ICs. So it seems that whatever drive ICs were fitted by the previous technician, because the amplifier had just been repaired, but it was an unsuccessful repair because it didn't work fully, so it got sent to me. And I located that the drive ICs that the technician had fitted weren't good. They were either damaged, or they were faulty from factory, or they weren't quite the right tolerance, or something was bad, or they weren't soldered properly. Something was bad with the drive ICs that were fitted. I think they were 4421 chips. So we replaced those, and the thing came to life, started working, and did decent power. Dude, get rid of your NatWest card. Well, you see, the NatWest card, actually, this is a dead card. This is a cancelled card, so it doesn't matter if you see the numbers or not, because this card is actually dead. And what I was actually going to do is I was actually going to destroy this card using my heat gun for you on live stream a little bit later. But I wanted to heat up the chip with the hot air gun and just see what happens when you heat up the little contact chip here. I thought that could be fun. What if I have a power light and right voltage, RCA is good, radio is good, but no sound? Definitely check that there is sound coming down the RCAs. You can do that with a pair of headphones actually as well. Check that there's sound coming down the RCAs. If you've still got no sound, then it could be a bad relay, could be a snapped inductor, could be snapped RCAs in the amplifier along the side, could be a bad preamplifier. There's literally hundreds of reasons that it could be not working. It's difficult to kind of tell you just from that diagnostic there. So let's continue with this. We've screwed get those MOSFETs that were getting hot back down to the board. So what I'm going to do now is I'm actually going to probe the drive waves and see whether there's any difference in how these FETs that are getting hot are being driven compared to the others. So let's go ahead and give this some power. Okay, I'm going to turn the current up a little bit more just to get the drive for working properly. And I'm going to turn my scope to AC coupling, turn it down to about 2 volts, so we can zoom right in on this drive wave and see what it's doing. Let's take you to my scope view here. So this is the low side drive wave of the FETs that are getting hot. Okay, so we've got a bit of a spike there, but that's because this amplifier isn't turning on fully. It's only being given about 6 volts after the current limit kicks in. So if we go over to the other side that's not getting hot, what does that drive wave look like? It looks the same. So it doesn't seem to be a drive wave issue. It's either a MOSFET issue or it's an inductor circuit issue after this, potentially. And I'm going to give it even more current because this would have been turned on in the car. I'm going to give it like 10 amps just to see if that kicks it into operation or not. No, it's sucking like 10 amps from the that's not right. It's drawing some hefty current. Definitely is not happy. Let's give it a little bit more voltage just in case it's that as well. So let's give it 12 volts and keep it down at about 6 amps. No, definitely not happy. So yeah, there's definitely some issue there with this part of the circuit. Alright, so this is getting slightly beyond a top board diagnostic, so I think what I'm going to have to do next is I'm actually going to have to take the amplifier out of the board entirely, out of the case entirely, and looking at this, because the drive waves look pretty decent, I'm actually just going to lastly check the high side drive, make sure that looks alright as well. The high side drive looks a bit funky actually. Got a bit of a spike on the high side drive there, but it's the same on both sides. See, that's the thing, if it's the same on both sides, I'm not too fussed because this side isn't getting hot. So this side seems to be working correctly and this side's not. So the first thing that I'm going to want to do given this scenario is take the board out of the heatsink, and I want to remove the inductors. I want to just let the amplifier turn the MOSFETs on and off and not give them any low pass filtering from the inductors, just to see if, just in case it, because this is a very classic inductor issue. This is really looking like an inductor fault. When the drive waves look perfect, you have good output switching waves, etc, but you have heating of some of the FETs and it draws a lot of current. That is a typical bad inductor scenario. So it could not be, it could be issues with the drive circuit, but that's just very typical of a bad inductor. Okay, so let's turn this off and let's start unscrewing this from the case then. Evening from Norway, says Stefan, loved your video from DD Factory. Thank you, that was an incredibly fun video to make and shoot. It was an absolute pleasure to be out there with DD in Oklahoma, and I plan on going back, I think May next year, May 2019. I should be back out there in Oklahoma, probably just for a visit again, probably for a little trip to see how those guys are getting on. And also they have like a mini kind of distributor dealer party thing, so that might be cool. It was suggested that I may be offered a job out with DD, maybe doing some R&D stuff or some promotional stuff, or I'm not too sure yet. I haven't spoken to Jasser about it yet, but it was suggested that there was a job out there for me if I wanted it, and we could discuss what it would entail. So that might be pretty cool. Might end up coming over to the States for a couple of years and working out there with DD. And obviously being in the States, I would still do some amp repair on the side, so if any of you guys have amps in the US, you'd be able to probably send them to me much easier than sending them to me over here in the UK. Is it weird to find shorted caps? Shorted caps usually happen when you have blown output FETs, because if you have blown output FETs on one side and not the other, then what happens is the inductor acts like a flyback power supply, and it actually raises the rail voltage by like 20 or 30 or 40 or even more volts than it's intended. And what that does is that ends up blowing all the caps. Capacitors usually only die on very old amplifiers, or where they've been subjected to a really bad, blow, or But yeah, the capacitors generally, I mean, in all these car amplifiers, the age of the caps are very young, and there's not much in terms of voltage spikes or anything that can kill the caps in these. So it's very rare. I very rarely see damaged, shorted caps. I've seen one or two, don't get me wrong. For sure, I've seen a couple here and there, but very, very minor compared to other issues like shorted inductors and things like that. This wire for this head cam is getting really annoying. I'm sure that wire used to be longer. I need to get myself a USB extension cable for that wire. It's like right on my arm. Very annoying. Those inductors are output filter. Yep, that's right. So that stops the subwoofer driver from getting the output switch wave from the Class D section of the amplifier. Hey Sam, why car amplifiers uses push-pull for the power supply instead of H-bridge? Some amplifiers do use H-bridge for the power supply. I've seen that done in Alpine before. Alpine, some amplifiers use a H-bridge for the power supply. But most of the reason that they don't use a H-bridge for the power supply is cost, and the design is already there. So what most people don't realise is that these amplifiers, all these Korean, Chinese, etc. amplifiers, they're all just designs that have been copied from one manufacturer to another. So they're like 15-year-old designs, and if it ain't broke, they ain't gonna fix it, because it costs money to redesign the amplifier section and to make it more complicated. So these push-pull power supplies, they work, they're relatively reliable, so why fix them? Why change it? Why spend money on and time sorting something out that doesn't need sorting out? So they just literally just continue with the same old push-pull configuration that's been in car amps since the fucking 90s. Yeah, there's literally no, they don't see fit any reason to change the design. But when you get brands like Alpine, who are actually employing, and also JL Audio, who are employing amplifier design technicians to actually design them a circuit from scratch, then obviously they'll use whichever circuit technology is available to them at the time within their given quoted costs. So that's why you tend to see better designed power supplies in those sorts of amplifiers where they've actually been designed with modern technology and parts and stuff in mind. Okay, there we go. Let's take a look at the bottom of the board for a sec and just check that there is nothing funky going on under here. So yeah, here's our output FETs. These are the ones that are heating up. So from the underside, it doesn't look like there's anything out of the ordinary going on under here. It looks pretty clean to me. There's no shorting or anything like that. Looks like maybe this amp has had some work done on it before in the preamp section. So if we take a look over here, so it looks like we've got some work being done over here around this area with the capacitors in the preamp section, but that wouldn't be causing the FETs to heat up, so we can ignore that for the time being. So the reason I wanted to access the back of the amplifier here is because I wanted to remove the inductors. or just desolder one leg of the inductor just to remove them from the circuit so that I can see what's going on here. If the FETs are still heating up with the inductors removed from the circuit, then because the drive looks good, I will assume that the FETs have gone out of tolerance or they're just bad. So I'll go ahead and remove the FETs and replace them temporarily with something just to get it up and running to see if it's fixed the issue. If the heating goes away once we lift the inductors off the board, then it's obviously the inductor or something after it that's the problem. Maybe these blue caps can also be leaking. So then we'll look into that further. So yeah, just one last time, what I didn't check is I didn't check to see whether there was any DC on the outputs, on the speaker output terminals. So what I'm going to do is I'm just going to go ahead and probe the out wire here and just make sure that there is no DC on the speaker out when we turn the amplifier on. So let's go ahead and crank it on. Okay, so there's no DC, but we still have excessive current draw. Yep, 6.9 amps, and we've got different FETs getting hot now. That's curious. So this time round, we've got the 9640s getting hot. And it's both the 9640s getting hot, and that's not usually an inductor issue, I don't think. I'm just going to confirm that with my thermal imager here. So why would suddenly the FETs that are getting hot change where they are? Okay, yeah, so that's very strange indeed. So now none of the low side FETs are getting hot, but we have the high side FETs getting very hot very, very quickly on both sides. So we've got both sides of high side FETs getting very, very hot indeed, but the low sides staying cold. That's really strange, because you saw it with me as well, didn't you, on my head cam, that it was the low side 1 and 2 that were getting hot. What the fuck? Just to prove that to you. So before we had like 1 and 2 here getting hot, but now we've got all of the high side ones this side and all of the high side ones this side. What the fuck? Okay. Could be a fun one tonight, lads. Okay. So when we've got an issue like this, I really don't think this is inductor related. But just to be sure, it doesn't take long to just remove them from the circuit quickly. Because they're seated really well. I really don't think that's an inductor issue. Alright. Okay, so the next quickest thing to do is either, what I want to do now is I want to measure the drive waves on their own, individually, okay? I don't want them to be powering the MOSFETs at this point. So I can either remove all the FETs, okay, that's one thing I can do, but that's quite long, or I can lift all the gate resistors, which might be a little bit quicker. So maybe I will lift all the gate resistors and do it that way. Yeah, I think we're going to go ahead and lift all the gate resistors. And so in order to lift all the gate resistors, it's very easy, and it's a quick way to do this to get the MOSFETs out the board, out the circuit. We leave the MOSFET soldered in, but all we're going to do is we're going to desolder one of the legs of the resistor and just pull it out off the board. The MOSFET still has the gate connected to the pull-down resistor, so no residual current will accumulate on the gate leg, so the FET won't explode after a while. But we just remove the gate resistor from the circuit so the MOSFET doesn't get driven, so it doesn't turn on, so it doesn't draw excessive current, and that allows us to probe the drive waves for as long as we like to see where the issue is lying, if it's a drive issue. So let's go ahead and do that now. Turn the board over. We have to actually figure out which resistors it is that are the gate ones, not because we don't want to lift the pull downs, we want to lift the gates. So it'll be the low resistance ones. So is it always the one that's closest to the FET? Yep, 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 in that case. Okay, so it's always the one closest to the FET that we need to remove. Cool. Okie dokie. Has to be something common to both channels. For Nano, this is actually a mono amplifier, so it only has one channel. It's not a two-channel amplifier at all. It's just a mono amplifier. But he is right in saying that it has to be common to both of these high side drives. So if it's common to both of the high side drives, then it's either going to be on the drive circuit that the issue is, or on the output circuit. Alright, let's remove the inductors first, because that's what we were going to do first. So I'm going to lift the legs of the inductors. So I think the easiest way to do that is we've got one there and one there. So if we remove the outside leg, then we can just lift it off the board very quickly. Let's go ahead and turn my soldering iron on. Sundown amplifiers are not worth what they cost. No, they're not. They're not bad amplifiers, but they're just very generic. Very generic circuit designs that you can pick up elsewhere for much cheaper. I really don't think it's the inductors here, but I've got to start from page 1. So inductors is the first thing that the first thing on my list. I don't think it is inductors, but it just gets them out of the way. Because if I don't try the inductors, then it will just be sod's law and my luck that it actually is the inductors at the end of the day. So it's quick to get them out of the way. Good evening to Fred. So who saw the picture of my DD-Z4s that Digital Designs put up on their Instagram and their Facebook page? Did anybody see that? They posted a picture of two Z415 ESPs with blue baskets, blue metallic large weave carbon cones, platinum dust caps, etc. Who saw those pictures? I don't think this was the easiest one to remove. Maybe if I can remove the whole thing from this side. Maybe the other side's going to be easier to remove, because that's the one that goes over the top, so I can just pull the wire out rather than having to pull the whole inductor out. David Tuitt saw them. They do look very nice, don't they? The colour combination worked really well. I was in two minds about the colour combinations for ages. I originally had them similar to my original 9915s with the red and white baskets and the platinum cap, but I last minute decided to change it up, go with the metallic blue, because I saw a photograph of that and I thought, yes, that looks really cool. And the basket has some kind of glitter kind of stuff going on inside as well, the basket paint, so that's pretty cool. There we go. Okay, yeah, that wire was much easier to remove than the one I was trying to do earlier, so let's do the same for the other side. We tried using solder wick for desoldering. Yeah, I do use solder wick quite often. It's very, very good, very useful stuff. However, for these large pads, you end up just spending ages going through a massive, great big wad of solder wick to get rid of all the solder, especially on these inductor pads here. It's much, much quicker just to heat the cunt up. Sorry, apologies. Not sure how that word came out. Just then heat the thing up and just suck it out like so. Much, much quicker than, because yeah, the desoldering braid like this, you end up using an absolute load of it, even on just very small pads that don't appear to have much solder on it, because it really spreads out across the wick. But it's really good stuff, really useful for small SMD stuff. What's inside that radio spares box? Oh, that is, that's rubbish, it's empty. There was some spare MOSFETs, but that's empty now. Okay, so the inductor is out of the circuit because we've lifted the two legs, the two wires on top of here, bottom here, so the inductors are no longer connected to the board. So let's hook up the power back and see if it still heats up. My inkling is that it will still get hot and draw current, but let's see what happens. Wow, well, that came up really quick. So yeah, we're still drawing excessive current here from the high sides. Yep, so that didn't solve anything. So it's not the inductors that's the problem. So it's going to be probably either a MOSFET or a drive issue. And it's unlikely to be a MOSFET issue because we have equal heating of all of the high side ones. So it's more than likely going to be some problem on here. Okay, so in order to see what the issue is with the drive, what we need to do is remove the MOSFETs from the circuit, but removing the MOSFETs themselves takes ages, so a quicker thing to do is just to lift the legs of the gate resistors, as I said a moment ago. If you weren't with me just then, to remove the MOSFETs from the circuit without actually removing them from the board, all we do is we lift the legs of the gate resistors here to stop the MOSFETs getting driven by the drive circuit, and that way we can probe the waves from the drive circuit itself without actually driving the MOSFETs. So that's what we're going to do next. Is that the amp from yesterday? No, the amp from yesterday is the JBL, and the JBL will be being worked on once the replacement parts for it arrive, the upgraded parts. It's now off the camera screen, so I'm just going to use this one for now. How many watts are you going to be running with the Zeds, says Rowan. I'm not entirely sure yet. I do have a band of 13K ready to go in, and I can run that at 0.5 because I've ordered dual 2s. But yeah, for the time being, when I first install the Zeds, it will initially be on a single LW audio 4500. So it'll be 4.5K, which is not enough, obviously, but that's just the amplifier that is in there at the moment. Shortly after that, it will be on two LW audio 4500, so 4.5K to each, which is again not really enough. But however, saying that, they will be at 0.25 each. So the amps will be at 0.25. So they won't really be 4.5K amps at that point. But they won't really be at 0.25 because the woofers have such a crazy high impedance rise that they'll be at much higher than 0.25 once they start playing. However, running it at 0.25 will give me massive scope of headroom. It will make the amplifiers feel like they are much more powerful than they are because the subwoofers are so goddamn efficient, which is one of the benefits of having efficient subs, is you can run down at a low impedance and it makes the amplifier feel much more powerful than it is without actually doing the power, because it's actually just the woofer's motor that's giving you the rest of the driving force. So yeah, there's that. So it'll be on 4.5K to start with, then 9K, and then probably 13K, and then maybe 26K with a pair of the banders. But I'm not too sure, you know, if some amp comes along, we'll see. It could be really fun actually to run the two Zs on one of those tiny bander pocket amplifiers, 250 watts. That'd be super duper fun, and see how loud we can get from like the world's smallest, like the tiniest amplifier, and the world's best subwoofers. Although probably Z3s would have been better for that because they're a bit, I think they're a bit more efficient because they've got a lighter weight coil. So yeah, the best subs for doing that funky test would have been the Z3s, probably not the Z4s, but it would still be a fun test. Are you really going to run banders? Yeah, probably. There's nothing wrong with bander at all. Bander makes superb amplifiers. How was the trip with DD Audio? Must have loved it. Yes, it was flipping amazing. Honestly, one of the best trips of my life. Fantastic time. Really good opportunity, and I massively thank Jassa and Chan and the guys at DD for the opportunity. Yeah, super duper cool. So now we're just lifting the legs of those resistors up, like I said earlier. So if I zoom in, you can see what I'm doing. So we suck the solder from the holes. Now we can just go ahead and lift up the resistors, which removes the MOSFETs from the circuit. Some of them are glued in, which is a bit annoying, but yeah, oh well. Okay, so I think that's all the MOSFETs, or the gate resistors lifted from the circuit. We can just double check that by taking our multimeter, making sure that there's no continuity to any of the gates. So we should see nothing on the meter here when we probe each of the gates on the multimeter. Cool. We are good in the hood. So now what that gives us the ability to do is to power the amplifier up, and it won't switch the FETs on, so they won't get hot. And that gives us the opportunity to measure and look at the drive wave shape to see why it's getting so hot when it tries to turn on. So let's do that now. Power on. Something sounded weird there. Did you hear anything come there? That was interesting. I'm sure I heard something funky go on there through the speakers. Okay. So, oscilloscope probe. Turn my oscilloscope down to 2 volts divide and AC coupling. And yeah, let's go ahead and turn her on and see. Okay, so now you can see we're only drawing 1 amp from the amplifier because all the MOSFETs are not being driven. So let's go ahead and have a look at these cheeky drive waves. We might not actually see any of the drive waves here unless we run, I think we're going to have to run a sine wave signal into the amp. Yes, we are. Okay, no worries. So some of these amplifiers, because they're self-oscillating, they actually need the whole feedback loop present in order to oscillate a wave. So we can force it to oscillate by taking the RCAs and putting a sine wave into the board, and that forces the drive waves to show themselves. So let's put our RCAs back on. Plug in the RCAs. Turn the gain down. Turn the subsonic low pass up a little bit, bass boost down, phase down. I'm actually going to go ahead and open Audacity on my computer here so that I can run a signal through. So we're going to generate tone, and I'm going to use 50 Hertz for this, 5 minutes. So now the drive wave should appear on the screen as a 50 Hertz square wave. Let's see if that is the case. No, don't have anything. That's strange. Huh. Maybe the input circuit is busted again. I'm going to check that we have our 50 Hertz sine wave going into the op amps here. Yep, we've got our 50 Hertz going into the op amps. So let's check. We should also have our 50 Hertz going into the driver board on some of these input pins. So let's just make sure our 50 Hertz is in fact making its way to our driver board. So there's some pins on the, maybe I'll use my head cam. So yeah, there's some pins on the driver board here. So one of these will be responsible for inputting the audio wave to the PWM drive. So if I go ahead and find out which one that is, keep pressing the wrong pedal. Alright, so it's not that one. It's not that one. Or it could be these ones, but they're just not working. It's not making its way there. Yeah, the audio signal is not making its way to the driver board. Ah, that's annoying. Okay, maybe we can trick this and bypass this by actually forcing the amplifier to take the signal into its slave, which should send it directly to the drive board. But just one last thing I'm going to try and mess around with here. Input, so it's definitely going to the inputs, yes. It's definitely going to the correct header. Do we have our correct plus and minus voltages on the op amps? So are the op amps actually working? Let's turn this up a little bit. So the op amps need plus and minus about 12 or 15 volts. So we've got plus 14 and we have minus 14. So yeah, the op amps are functional and working, or should be. We just don't seem to have our audio wave anywhere present. Even if I turn the gain up and down, it doesn't do anything. It's not making its way to the rest of these op amps. It's finding its way to the first one here, as you can see, but by the second one it's not there. Okay. Alright, I'm going to just, for the purposes of this, I'm going to go ahead and try and run this into the slave input, because that should bypass all of this stuff going on over here. So bridge in is this one here. So let's turn the signal down on the computer a little bit because it's a much lower signal going in to the bridge. And let's try this again now. Okay, there we go. So there's obviously some issue on the preamp section, but running it into the bridge in seems to bypass that issue for the time being. So let's just take this as it is with the bridge in and have a look at the wave like this. Alright. So this is... Oh, something smells hot. Why does something smell hot? Wow, something smells really stanky. What the fuck? There's like a plasticky burning smell going on here. Ooh. Wait. One side of the driver board is running crazy hot. The contrast on my camera isn't good enough. This is so annoying. This camera's a bit shit. But over here, this is like yellow and this is red. But the contrast on my head camera isn't good enough. It just looks like one big white blob here for you guys. But here, it's much hotter over one side. Oh, there you go. That's a bit better. You can see it's much hotter over this one side of the drive board than it is the other. So that's interesting. That could be what the issue is. Then we could just have bad drive transistors on the driver board. But we've also got a problem with the input board because, well, our RCAs aren't working, are they? Our normal RCA input doesn't seem to work, but there's a very nasty plasticky burning smell going on, and that doesn't usually come from transistors. That usually comes from capacitors or something like that. So I'm just going to go ahead and turn it on once more and see if anything else is getting hot that shouldn't be. Helps if I hit play on Audacity. So this side of the driver board, wow, yeah, this side of the driver board is reaching like over 100 degrees. Yep, so it looks like we have issue on the driver board then, my friends. I'm pretty sure that's issue on the driver board. It's very hard to pinpoint with this piece of crap. Thermal imager. So I'm going to just double confirm that by taking some alcohol spray, and I'm going to go ahead and spray over here. I'm going to spray the drive board and see whether the spray actually evaporates. So let's turn her on. And I wonder whether the drive wave will look like a really bad shape over this side. Yeah, the drive wave is non-existent over this side, so that's definitely what the issue is. So yeah, let's go ahead and spray. Yeah, it's the two AG and DKs on this far side that are getting super hot because it's evaporated instantly from those two. Cool! So that's what needs changing then. Pretty simple stuff. Fingers crossed. Oh no, hang on a minute. I wonder whether I made a solder bridge. I just had a thought, because I don't think that wasn't getting hot before, so I wonder whether that's actually my fault and I've made a solder bridge on the drive to the pull down resistor. I probably have, haven't I? That's probably why they're getting hot. Yeah, I think that's my fault. Look, so what I've done, I think, is I forgot to check this, I wasn't careful. I think I've just connected this to this. So I've just bridged this gap here. So actually it's just grounding whatever signal was on the drive. So that's probably why that's getting hot. So let's remove that solder bridge. See, I called that before I even saw it. I knew that was going to be what it was. So that doesn't actually help us with our original problem. So now that we've removed that solder bridge, I bet that those two transistors aren't going to be getting as hot. I wonder whether I damaged them by getting them that hot. Yeah, always check for solder bridges, guys. Don't do like me and forget. Yeah, so now we're only drawing 7.7 amps, which is much lower, and we do have a drive wave. So yeah, that was my bad. Okay, but the drive wave does have a bit of a spike on it, as you can see here at the start. I wonder if that's prominent among the rest. It seems to be prominent among the rest, so that seems to be the common thing that happens. Okay. Right, so all the drive waves look fine. Oh man. So we have a 4.0, literally a 4.0 volt sideways square wave there of the drive. Four point zero. 4.0. 4.0. So the drive waves are equal throughout. fucking hate these ones that don't make any sense. So why is the high side FETs getting hot? It could be that the FETs are not good, so we could remove the FETs and replace them, but that's very rarely the case. The FETs usually either work or they don't. A while back you did a repair of an SCV-1500D. What happened to the video of it? They're all still on my YouTube, but I need to edit that video because that was a long ass video. That was like the Sundown 6K was actually split over about 5 days, so there's an absolute shit ton of content that I need to edit for that one. So I'll put that one up eventually, but yeah. Alright, so why are you getting hot then, man? Okay, I'm going to put all the gate resistors back in because I've done everything I can do with the drive waves. The drive waves appear to be all unique and the same. One more thing I'm going to do is I'm just going to compare the drive waves on the actual driver card itself. So what I do is I'm going to go ahead and probe all of these tiny little transistors on the driver card and confirm that the drive wave is how it's supposed to be all the way over there. So we've got 1.9, 4.2, 1.9, 4.2. Hey, what the fuck? What the fuck? Why is there a sine wave on the back of the FET? That could just be a weird grounding thing with my scope probe, and that's not actually there, but that's a bit strange. Why would there be a sine wave on the back of the FET when there's nothing driving it? It's on all of them, isn't it? Yeah. Right, okay. There's nothing on the outputs. Merp. That's a strange one. Never seen that before. Okay. Right. Eternal Twig says, didn't know you're still alive. Of course I'm still alive, man. Solder bridges doesn't really make sense, because for there to be a solder bridge that sends the sine wave to the back of the FET, there would have to be some massive solder bridge that goes all the way from here all the way to like here or there. It's definitely not a solder bridge. That's really weird. Right, well, let's put the resistors back in for the gate drive, and then now obviously the amplifier should still probably get hot when we turn it on because we haven't changed anything. So when I put the resistors back in, I'm gonna actually make sure that there's not something weird going on with the RCA inputs, because if for some reason the drain of the MOSFETs is connected to the RCA inputs, that would cause massive issues. So that's something that I'm going to check. I'm also going to reconnect the inductors back up because removing those made no difference whatsoever, so we might as well put those back in just to complete the circuit. See, I'm going to use my solder wick now to remove the old solder from the leg of the inductor. So I use it for jobs like this. Ow. And I also burn myself on the solder wick on regular occasions. Being a little bitch. Go back in the damn hole. I hate this when the lead is now slightly bigger than the hole was somehow. To get some of this and have to get something to shield my finger so I don't burn my finger when the heat travels up the lead. And I have to heat the shit out of that. Wait for it to pop through. Oh geez, come on. That should do it. Let's just make sure that popped through the other side. Yeah, kinda, it'll do. There we go, that's popped through properly now. Okay, now the other side. There we go, the other side goes back in perfectly. Nice and easy. I just have to apply the solder. Okay. So we were confused last time as to why the hell there was sine wave on the drain of those FETs. So I'm going to turn the amp on again, and I can't keep it on for too long because obviously the FETs get really hot. But what I want to do is I want to have a look at the RCA section when the Class D switching is active and see if the Class D switch is anywhere hiding in the preamp section where it shouldn't be, if there's a short somewhere. So now that's all back and connected in, let's go ahead and fire her up and see what we got going on. Okay, so yep, thing comes to life, and it looks like we're drawing a lot of current again, which is normal, so as we expect. Okay, so let's go ahead and probe the RCA input stuff. So let's go ahead and probe this one. Okay, so there's nothing on that one, nothing on that one, nothing on that one. Okay, so it seems pretty safe. Wait a minute. Wait a minute. I found something out, guys, about this thing. Oh, man. Right, today we gonna learn. So this is the second time that I've seen this happen with this type of amplifier. Are you listening, guys? Alright, so I just had an inkling then, because I remembered back to an in-phase amplifier that I repaired that was the same circuit design as this, and I had the same problem. I couldn't figure out what it was, and then I solved it by just fucking around. Right, so with these amplifiers, watch what happens. Okay, these amplifiers that use 640N and 9640s and AG and DK drivers. Okay, these specific amplifiers only. This is only a problem with these amplifiers. So if we probe the output drive wave, okay. So what we do is we set our bench up like normal, where we're giving the amplifier between 3 and 5 amps in order to turn on, okay? And let's give it like, you know, let's give it like 12 volts as we would do normally, so we know the amplifier's, you know, going to work on this voltage and it stabilizes itself. So if we try and turn the amplifier on, we get like the drive waves trying to build, okay, but it doesn't, and the high side FETs get hot, right? So you would immediately assume that there's a problem here with the amplifier. Why can't it turn on? So you think, okay, well maybe it needs a bit more current. So you bump up the current a little bit to like 6 amps, and that's more than enough. That is more than enough current for every other fucking design of like 1.5K amplifier in the world. So you bump it up to 6.5 amps, you turn it on, and it comes on this time, but it draws like excessive current. You've got 6.3 amps there on the power supply, and the high side FETs get really hot. And so you're like, ah, shit, there's a problem here. So as I just did, you start pulling the board apart to try and find out where the issue is. However, there isn't a fucking issue anywhere. The amplifier is fine. The resolution for this is this amplifier for some reason needs a massive gulp pulse of energy in order to turn on properly. So you have to give this thing around 15 amps or more because it's at 12 volts. Let's give it 20 amps. Let's give it the maximum that my power supply can provide. 20.3 amps is the maximum this supply can provide at 12 volts. So now let's turn it on and watch what happens. Oh look, the drive wave builds perfectly and we're only drawing 1.9 amps. What the fuck? Right, so learning curve then. With this exact specific style of board, in order to power it up properly and for it to work properly, you absolutely have to give it a decent amount of current for it to start operating normally, which is only a problem with this style of amplifier that uses AG and DK drive transistors and 9640 and 640N MOSFETs on the outputs, and that goes for the Sundown SAZ-1500D, the the in-phase power drive, IPA, in-phase IPA 2000 as well has this problem, and maybe the solid audio F2500D also has this problem. Any amplifiers that use this style of amplifier, this board design, you need to give it a decent amount of current on power up for it to start working properly and for the stuff not to heat up and start giving problems. What a fucking wind up. Okay, cool. So so it doesn't seem like there's a problem with the amplifier, but there is a problem with the input circuit. So there is still something that we need to fix here, alright? Because we discovered by looking at this earlier that for some weird reason we don't get any RCA signal coming through the amplifier to the drive board. So if we stick our RCAs back on just like this now, alright, I'm going to put RCAs back on. We're going to turn the voltage back down from 12 volts back down to a safer voltage that I like the look of more, around about 9 volt mark. And so we do need to find out what the problem is with this amp, because it's not actually passing audio to the drive board. So I've still got Audacity running, and so we're going to go ahead and hit play on Audacity, and I'm going to actually hit loop play so it doesn't stop. And we're going to try and follow the audio wave through the board and find out where the dodgy component is that's preventing the audio from passing. So let's take our scope here and zoom in to what needs to be done for 50 Hertz. Turn the amplifier on again with 20 amps worth of boof. There we go. We're up and running. So we have our sine wave here. Let's give this a bit more power there. Yeah, so we have our sine wave here entering, and it's making its way to the first op amp. So the first op amp is just here. So it's making its way there. However, it's not making its way to the speaker terminals. So it's not making its way to the driver board either, because this isn't oscillating with the sine wave. So there's some component here that's not passing the sine wave from one side to another. And I think it's going to be a capacitor. These Sundown amplifiers are notorious for having these small blue capacitors fail, and they don't pass any audio signal through them. So let's have a look and let's see if we can find our audio signal. So we got the audio signal there. We don't have it on this side, but this is a different type of capacitor. We don't have it on any of the legs of this op amp. So it's probably going to be after the gain pot, and it's probably going to be this first capacitor here that's the problem. So let's very carefully turn our amp over. It's still going to have high voltage on the board because we just turned it off, so very carefully not to short anything out. Turn the amplifier upside down. Okay, and so the capacitors are starting, where's the first one? First one's like here. We've also got a capacitor here, and this does look like it's been worked on before and soldered on before. So let's turn it on again and start following the signal through. So do we have our sine wave on our gain potentiometer? Oh no, that's our phase potentiometer. So we've gone over to the other side of the board here. So we do have our sine wave on our gain potentiometer, and do we have it on the other side? Yes, we do have our sine wave on the gain potentiometer on the other side also. Okay. And we do have it very, very... there we go. Look on the outputs here. I think it's a dodgy gain pot. As I wiggle the gain pot around, you do start to see some output on the scope here. Look, check this out. If I probe the output here and I wiggle the board around, come on, it was doing it just now. Do the ting! Come on. You did see it though, right? As I was playing around with this, the wave did appear briefly on my speaker terminals. And it is there very, very faintly, right? If I zoom right in, if I go right down to like 100 millivolts, it is there incredibly faintly, okay? So it is there. I think we've got a dodgy gain potentiometer perhaps. Okay, let's flip the amplifier back over the other way again and start prodding some things on the board and see if we can find out which part it is that's dodgy. Could be a capacitor as well. Okay, so let's again probe over here and let's have a look. See it there on the screen. It's almost there. I need like some plastic tweezers to start fiddling about with the board here. We've got some plastic tweezers so I don't short anything out. Okay, so there is actually a way to trick this and to prove this, and that we can actually jump over the gain pot. So if the gain pot is bad, I can jump over it, and that will prove whether the gain pot is bad. Oh, wait. What's going on here? Whoa. What the fuck? Something went weird. Something fucked then, did you see? Was that clipping? That might have been clipping. That might have been the wave that was clipping because I just made the connection again. Either that or I fucked something up. But I've got plastic tweezers, so that shouldn't have made a connection. So let's turn the current back down. Let's just make sure that that's going to work. So using the plastic tweezers shouldn't have done anything. Oh look, there we go, it works now. What the fuck? What did I do? I prodded something with plastic tweezers, so it must be a dry solder joint. Must be one of these resistors over here. I'm scared now, so I'm going to turn my current down on my... Because now the amp's on, I don't need excessive current, so I can turn the current on the amp down to like 3 amps. So if anything happens, it doesn't draw excessive current from the supply. So if I prod that same area again, that was this resistor, or that looks like that looks like it's this. It looks like it's this op amp here. Maybe with some dodgy leg, because it's wobbling the sine wave as I play with it. I need something non-conductive but a bit stronger than these plastic tweezers. Yeah, there we go. Look, as I wobble this leg, the sine wave kind of wobbles around with it. And it doesn't. I don't think that happens with any of the others. Oh no, it does. Huh. Okay, well I'm just going to go ahead and refresh all the solder on all of these. It's not the gain pot, because the gain pot does work beautifully fine, really nicely. It's not any of the other pots. Not the phase. Here we go. That's fucking it up. Okay, so that's the first. There we go. That looks really, look at that. Okay, so that's wobbling around the first. Oh, whoa, okay. I think these tweezers are actually conductive, even though they're plastic, because it just sent it into protect then. That's annoying. What the fuck? I was probing it with fucking plastic tweezers, and now it's drawing excessive current when I power it up? What the hell is that all about? Alright, now it's not anymore. Okay, it's fine. Whew, I was getting worried then, you know, guys. Well, it's definitely something to do with those this area around here. So I'm going to go ahead and resolder that, and I'm going to go ahead and do an endurance test on it. And yeah, if it passes the endurance test, then I'll just go ahead. It will just be a cold solder joint on this one. So all that work, and it was just a cold solder joint. But we did learn that on these boards, you do need to power them up with a high current, because it demands a big spike of current as it goes to turn on. And if it doesn't get the desired current on the spike to turn it on, then it will massively heat up the output section FETs and cause damage. What got going on in the live chat now? Beverage, I'm liking the stream about to start music on the recording of the previous stream. Is it something you made? Yeah, I made it years ago. Yeah, when I was like 16 or something. I was looking for like some kind of backing music that wasn't obviously YouTube licensed, like whatever. So I'm looking through shit that I made back in the day when I was in my teens, and I found that, and I thought, well, that sounds pretty cool. It's got the Bearvidge beatbox thing in it that I made. If any of you didn't see that, on my streams now, when my stream is about to start, like during the first 2 minutes, I play this little clip here. So yeah, that's a little clip I made for the start of the stream, and that's the music. Yeah, I was fucking around on the Cubase, and yeah, that's what I came up with. Can you do a video breaking down your amplifier repair equipment? Maybe some places you suggest for beginners, some tips and tricks, says Ronald Jones. Yeah, so basically I'll just go through really quickly with my handheld cam here, but I'll take it off my head so I can point it in the right place. So essentially, most important thing that you need is a current regulated power supply. Something, so you want something that can provide up to around 20 amps of power, but that can limit the current. So with this, I have the ability to go anywhere from like 1 volt, which is really, let me take it out of the amplifier so I don't have the capacitors fucking around with that. So I can go anywhere from like 0.1 of a volt, like this, all the way up to 20 volts, or actually 16.3 volts. Sometimes I can go up to 20 volts, depends on the current that I'm pulling at the same time. So yeah, anywhere between 16.3 and 0.1 volts I can go between, which is really important because it's safe to start off at, like, when you're repairing an amplifier, start off at a low voltage, like 10 volts, and then when you think you made a good repair, bump it up to like 14.4 and then test it again and make sure that it's fine. It's much safer to work on the amplifier when you're running it down at 10 volts because there's much lower voltage on the rails and you get more warning time before something explodes or gets too hot. It's very important to be able to limit the current. So on this amplifier, it was actually the current limiting that was causing my problems and gave me a massive waste of time this evening. But usually, on 99% of amplifiers, depending on what size they are, you want to fire it up with between sort of around 4 amps, or on bigger amplifiers, maybe around sort of 7 amps. On these boards, you have to give them at least 15 amps to power on with, and then once it's powered up safely and hasn't exploded, you can go ahead and crank it down to around 3 amps for operation whilst you probe things. So that's incredibly important. My soldering iron is actually kind of junk, but it's what I have anyway. It's an AOUA 2738A, so it is a hot air SMD rework station as well, so I can do air surface mount soldering with a hot air gun, and it also has obviously the iron attachment and the fume extractor. So my soldering iron has the iron tip and it also has a fume extractor nozzle on the end here, which sucks all the nasty fumes from the flux and the solder away from you as you're soldering. It just sucks it right up through there. The only annoying thing is obviously this doesn't really have a filter, so it all gets super clogged up, and it's a really cheap bit of kit, but it works fine. All the temperatures are all adjustable. So obviously the soldering iron temperature is adjustable, regulated, as is the hot air guns regulated, and the hot air pressure is regulated as well. So pretty cool. Oscilloscope wise, I have a HP 54602B, which is absolutely brilliant. You don't need something quite as complex as this. However, I find it extremely useful because it gives me a true volt RMS reading of whatever it's doing. It gives me the frequency of the wave that it's reading, and it also gives me the ability to stop and start the wave, so I can kind of pause it on a wave. If the amplifier is getting super hot within a second, but the wave looks bad and I want to analyze the wave a bit better, I can quickly pause it on the wave, turn the amplifier off, and then analyze the wave whilst, without the amplifier exploding in my face. It has other really cool functions. It has the ability to, has different trigger functions and slope coupling, and you can also do channel math, so you can add or subtract channels 1 and 2 from each other, which gives you, allows you to see the sine wave on the outputs of a Preamp amplifier, for example. Many super cool functions that this has got, and you can also play Tetris on it by going into utility, and it's one of these buttons you have to hold down, but I don't want to do it because for some reason it erases all your settings. So, but yeah, you can also play Tetris on it, which is pretty cool. So yeah, that's that. I have some basic tools that I should probably get better. I've just got like needle nose pliers. I just use a really cheap basic solder desucker, which is the quickest way that I found at the moment for doing things with. Other general shit. Loads and loads of Allen keys. You need shit tons of Allen keys when you repair amplifiers. Tweezers are super important. I have some kind of duck bill tipped ones here for bigger ICs and for getting rid of putting resistors back in place. And I also have somewhere, but they always go missing, some very fine point needle tweezers. But yeah, oh wait, here they are. So this is super useful for pretty much everything else, for doing surface mount rework with ICs and with tiny capacitors or resistors, things like that on surface mount. This is super useful. I use this Pro Wick, which is superb solder wick. It has flux inside the wick as well, and it's just the right thickness for most of the stuff that I work with on the amplifier side of things, so super cool. Tessa tape is incredibly useful stuff, especially for making good any rubs or shorts on inductor coils. If you've got the coil that's good but you've got a little rub, you can wrap some Tessa tape around it, which is like a fabric tape, and it's incredibly sticky and it's industrial use. Very good stuff. Multimeter, I don't have a fancy multimeter. I use just the cheapest crap you can find. It works perfectly for me. I know how it works. It's simple. It doesn't take ages to decide what scale it needs to be on. I just set the scale to whatever I want it to read, which is, I prefer to tell it what scale I want it to read. And it has the diode beep setting, which is super important. It also can read, it has a temperature sensor, degrees Celsius, and I've got a little temperature probe up here. So if my thermal imaging camera isn't accurate enough and the alcohol spray method isn't working for me, I can go ahead and put some little thermal paste on top of an IC and read the temperature with my super cheap multimeter. So the thermal imaging camera is a K-Moon from Amazon. It's a really cheap one. It's not that great. I wouldn't recommend you get it. The focusing isn't that great between the camera and the infrared sensor, so if you get too close, then what you're actually looking at on the screen and what's getting hot is kind of, it's not actually on top of each other, it's like above and below each other, so you have to kind of compensate for that or zoom out and then you don't get as much detail. I would probably recommend getting like a FLIR or something, but I haven't done that. For live streaming to my YouTube channel, I have a super old PC which is running LGA 775 chipset. It's P40, hang on a minute. EP45, yeah, so it's a Pentium, what is it, EP45 chipset I think it is, and I'm running a X5470 Xeon chip modded, which is a 771, DDR2 RAM, 8 gigs of RAM, and a 560 Ti graphics cards. It was all super old technology. But I can live stream to YouTube. I've got twin monitors, old fucking monitors as well, because this is just my workshop, so I don't care too much about it. For music, I've just got my old transmission lines from my bedroom setup from years ago. The tops for my T lines are actually here in the workshop, and I've blocked off the original tweeter holes, turned them upside down, and just quickly duct taped some tweeters to the top. And this sounds fucking beautiful. These are some Digital Designs A-Series 5.25s, which I had to cut the holes bigger to fit. But honestly, I have never, ever in my life heard a pair of bookshelf speakers that sound anything like these. I really want to rebuild these correctly, so that obviously, you know, just build them again from scratch with the correct tweeter locations and make them look pretty, because I am in love with how these sound. They're absolutely amazing. I think they're 50. I think the T lines are tuned to like 50 hertz, but because they taper inwards, I get a better low frequency, shallower low frequency roll off, so I can play down to about 35 hertz with these, or slightly under. They don't drop. They do need a sub for the lower stuff, but I can get like a decent 38-40 hertz out of them really nicely, and they sound so warm and beautiful and incredible. I love how these sound. They're just currently running off a Yamaha power mixer for the time being. I was trying to use a Technics SUV60 that I got off eBay for £10 that was in a horrific state, but it seems to turn itself off after an hour's worth of usage, and I can't figure out why. I have tried to repair it, but can't seem to figure that one out, and it's a bit of a waste of time. I've got better things to be doing. So yeah, there you go. There's a little quick overview of the stuff I use. I don't think I've forgotten much. So just before I go this evening, I'm going to go ahead and actually burn my old debit card because it's been cancelled, so it doesn't really matter. So yeah, I don't really care if you guys can see any information on here, because this card is cancelled, it's dead, it's gone. So let's go ahead and turn my hot air station to the maximum temperature possible, and let's get some burning. I want to burn the chip here and see what that looks like when it's really burned. Ooh, starting to raise, it's starting to bubble. Look at that. Has anyone noticed that the chip layout pattern on these cards is the same as a SIM card, I think? I wonder what would happen if you put one of these chips in your phone as a SIM card. I mean, it wouldn't work, would it, obviously, but it'd just be interesting to see that happen. Ooh, lovely. It's actually burnt a hole in the bottom. So you can see the chip there. I guess the chip is inside this bit. Yeah, where the actual information is stored. Cool. See if I can draw a smiley face on it. It looks really gross. It's all like brown. Ta-da! How about the hologram on the back? I am going to cover up my signature though. Cool. It kind of goes matte after a while. It kind of goes super shiny like foil, and then it goes really matte. And it starts to go brown and crack. How about the magnetic strip? Ooh, that's cool. It's like it's alive. Let me get this more into shot. Look at the magnetic strip when you do that one. Yeesh. It's like a pimple. Wah! Bloop. Bloop. Ah, that one wasn't as good. Bloop. Yeah. Bye bye. What else we got going on in the live chat? Jan says, I was going to watch a movie, then I saw you live again. I'd much rather watch this. Grab some popcorn. Ah, cheers. This live stream is not better than a movie, but I appreciate that. That's fucking cool. Thank you, man. Some passive radiator talk. Passive rads are pretty cool. Thanks for your channel, says Andre. Glad to have had you in the US. Come again soon. Thank you, dude. Much appreciated. Alex says this is oddly satisfying. I'm glad you find it satisfying. I find it satisfying when I repair an amplifier, and slightly less, still satisfying but slightly irritating when I figure out that the amplifier didn't actually have any problems in the first place where I was looking at it and just needed more flipping current to turn on, because that makes no sense. I mean, what 1.5k amplifier needs 20 amps of a sharp pulse to turn on? Like, most amps just ramp up fine, but this one needs 20 amps to turn on. But we did seem to fix the input RCA problem somehow, and I will go over that with my soldering iron to make sure that it's good. It's a happy burnt debit card, yeah, it is. Have you ever tried to put a sub in a barrel like a 6.5 inch DD506 Redline into a sewer pipe? It's fucking awesome. It's stable as shit. Yeah, MX Forest, that's like a pipe or a tube is actually the ultimate speaker enclosure because it doesn't have any weak points. So if you think about like a square box needing bracing because it has flat panels that will vibrate, that will flex out when there's high pressure inside, well, a tube won't do that because it's very, very structurally strong. A cylinder is one of the strongest shapes around in terms of strength from internal pressure, compression and expansion inside, and secondly it's incredibly strong like as a column pushing down. So yeah, like in terms of like internal pressures and stuff like that, they're superb, and it's also why aero ports are very good as well because they're an incredibly strong structure. So yeah, for sure. And also a pipe has no parallel sides, so you don't you get. Hang on a minute. Yeah, I think that's right. You get less stuff forming harmonics and shit, bouncing around inside. So pretty cool. What parts did you get for the JBL in the end? I haven't actually ordered them yet, so I'll need to do that probably after the stream. I'm from South Africa. Ashen, hopefully you didn't have any amplifiers left with the BD repairs and Louis, because I believe he's come back to the UK and I don't think he gave all the amps back, according to some posts over here. So hopefully, yeah, because South Africa he was doing some repairs in, so hopefully you didn't have anything with him. I have a DC 5K that heats up one bank of FETs on the power supply. Replaced all the power supply FETs and resistors. What's your take on that, Sam? Initial Pro, you probably have either you probably have some damaged driver transistors for that bank, or you have the transistor that bank is running. The transformer that bank is running is slightly shorting. So you need to take a look at the drive waves. If the drive wave is beautiful and is identical to the other banks that aren't heating up, then it's not going to likely be a drive issue. So take your oscilloscope, look at the drive wave of the ones that are heating up, and then move to one of the ones that isn't heating up. If the drive waves are absolutely identical, then it's unlikely to be a drive transistor problem, and it's likely to be something on the external side. But if the drive waves do differ in any way, then it's likely to be a damaged driver transistor. If the drive waves are identical, but the output waves on the backs of the FETs between the ones that are heating up and the ones that aren't are different, then it's likely to be a shorting transformer, or those FETs are slightly damaged or out of tolerance or not quite the correct specifications, and they're fighting each other. I think that's it. Or you could also have a bad pull-down resistor, but that's quite rare. Alright, lovely stuff. So yeah, guys, this amp doesn't really have anything wrong with it, just some dodgy solder connections in the preamp circuit. So thanks very much for tuning in. Yeah, actually, just before I go, I'm going to do one more thing. I had been struggling with another one of these amplifiers for quite some time, and it was exhibiting the same problems as this one was, in the sense that it was heating the FETs up when you try to turn it on. But on that one, I didn't try to turn the current up to see whether that would fix it. So I wonder whether that amp is actually fine. So I'm just going to put this one to one side for a moment and go and get the other Sundown SAZ-1500D. Here she is. So I was having the same problem with this one, but I bet it works fine, and I just wasn't giving it enough current to turn on. So I haven't actually soldered the driver board back in fully on this one, so I should probably go ahead and do that. So let's just solder the driver board back in on this one and do the same experiment. Do the same thing where we turn the current up. Ashen says, I started my own technical repair shop and your bits have been invaluable to me with troubleshooting and repairing. Awesome, dude, that's wicked. Massive props on going at it. And also that's really cool because now that Louis has left South Africa, that's one less competitor for yourself to deal with. So that's pretty cool. You should be getting some decent business as long as you're genuine, and as long as you're a good businessman, and you offer offer your warranty for 3 months or whatever it is you want to do on your amp repairs. I mean, I don't offer a set warranty on my amp repairs for a set amount of time. It depends on what the amp is, how the customer is using it, what the issue was with it, what the condition of it was when it came in, etc., etc. But there are times when I will I will offer the warranty, and I will actually do a repair under warranty if it fails again within what I perceive to be a fair timescale. So actually, do you guys remember the Sundown 6K that I did not long ago, a few weeks ago before I went to the States? The fucking amp that took me like a week to fix and was a massive headache, pain in the arse with the regulation circuit and all that. Well, that amp came back, completely blown again. Power supply and output section completely exploded once more. Very, 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 very frustrating indeed. However, I fixed it under warranty because he had only had it for a couple of weeks, and the guy is a nice guy that I know, and I know how he's using it, and he explained what he did when it blew. He said that he just, it was the same issue. He turned the engine was off, but the amp was on. He started the car, which would have turned the amp off and on again very quickly, and it exploded again. So it was actually very legit. Like I can totally believe him that that the amp died again. So I just repaired it completely again, fully under warranty, no extra charge. And I changed a few things on that Sundown 6K to try and rule out what caused it to die again. Because when it left the workshop, I don't know if you guys saw the last live stream that I did when I fixed it. I power cycled that thing like a freaking million times to absolutely make sure that it wasn't going to blow. And it seemed beautiful. It was working really well, and I endurance tested it for 45 minutes, and I bench tested it to full power. It did well over 6K. So I was very confident that that was a good, solid repair. However, yep, 2 weeks down the line, the amp blew again. So, that's not fair for the customer to fork out another whole bunch of cash when, he didn't do anything wrong. There was no reason that the amp should have failed again. So that is a warranty issue, and I did the repair again for free. And I've changed a few things so that hopefully this time, whatever caused it to go again won't happen. Wow, holy fuck, I completely forgot how fucked this amplifier was when it came in. This was a massively fucked amplifier. Alright. So yeah, let's go ahead then. So this amplifier was super duper fucked. I didn't do a live stream on this one, but this amp came in with a snapped and shorting power supply transformer, and now this could have been an extremely expensive repair. However, what I've done is I've done the repair for there's a good friend of mine, and I said to him, do you want me to just kind of fix the transformer rather than rewinding it? So I've had to extend the transformer from the base here to meet up with the original legs, and we're going to wrap that in some Tessa tape once we're finished with the amplifier. So that's soldered back onto there now, and that's not going to be going anywhere, and the power supply works perfectly fine on this now. We also had some massively blown traces in the middle of the amplifier here. I had to run a jumper wire from the small voltage generation part of the transformer for the ICs. This trace here, there was a trace that ran all the way along here, and that trace was completely blown. So I had to run a new trace there to that resistor. There was a few other bits and pieces that were exploded as well. I think from memory the amplifier section was actually fine, which was really confusing me because it was heating up, but I think I understand now why it was heating up, because I wasn't giving it enough current to turn on. So this could explode in our face, but let's just see what happens. So I'm going to go ahead and turn the power supplies and all that on, and we're going to see whether this exhibits the same issue. I'm going to give it our full 20 amps, and it might explode or it might actually work. going to turn actually my scope back to the correct settings to view the output wave. Reject low frequency. Would help if my remote wire was in. Okay, why you no work? Oh yes, I removed the thingy from the thingy. 1 second, guys. There we go. It works fine. I think 2.8 amps. Oh man. I mean, I think it does. The FETs actually do run a little warm, a little on the warm side. Let's just run that for a bit longer, just to confirm. Okay. No, the FETs are actually getting a bit warm here. So I think I do still have issues on this one, but less issues than I thought. Fucking bullshit old board designs. What? Oh, the reason they're getting hot is because the inductors aren't connected. I disconnected the inductors on this one as well to try and figure out what the fuck was going on. So I reckon if I reconnect the inductors, this is probably going to be fine. All right, let's bang the inductors back in, because I really want to. Because that'll be great if this works now. Because I can actually get the money that I need from this amplifier repair. Because this one took me a little while. There was a whole bunch of shit going on here. Where's the British chick? Ha! Ashley is wonderful, and she is in Bristol at the moment in the UK. Lovely town, lovely place called Bristol. Wonderful, beautiful place. She's super cool. I've been giving her driving lessons. She's just a friend. There's nothing there. It's not like that. But she's an extremely good friend of mine, and I've been teaching her how to drive, and she's doing really well. And she's a super cool chick. She's not like your typical like thought or anything like that. She's a legitimate, intelligent, interested, cute girl, and she was really curious about amp repair just because she loves learning new skills and she thought it was fun. Yeah, she's one of those really cool girls that just like is totally up for trying anything, and just, yeah, she's wicked. Good old Ashley. And she doesn't wear makeup either. She's I mean, not that's a good or bad thing, whatever. It's just her choices and whatever. But she's a super cool girl. She does science at university. She's a bit of a scientist. Doesn't wear makeup, but she's actually naturally very pretty. She's a very, very pretty girl, and like just naturally, and on occasion when we've been like going out to a nightclub, or there's been like a posh restaurant or something, and she has dressed herself up, everyone in our friend group is like, whoa, damn, Ashley, like, what the hell, where did that come from? Like, because she doesn't usually dress herself up, so you don't usually see her looking all fancy. But when she does, she's very beautiful. But she's beautiful anyway. But you notice it more, and you're like, oh wow, okay. What would cause the DC5K to draw more current than it should? Oh, a whole bunch of reasons, my man. Out of tolerance output FETs, bad drive waves, shorting inductors, shorting transformers. But like literally, there's a lot of reasons that they could draw more current. Boom, 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 boom. It was a great vid as it was very informative. Oh, thank you. The amplifier that we did, that we repaired or tried to repair in that one where the British Scale tries to fix the amplifier, that's actually still waiting to be completed because I haven't actually ordered the. It ended up having a very, very, very fucked output inductor that needed completely rewinding, but I haven't actually ordered the copper wire yet. Still to this day, because it's an amplifier that I personally own. Oh, what the fuck! The old fucking, what time of year is it? Is it cold season? What is it? Yeah, so because it's one of the amplifiers that I personally own, it's not a priority in my business. My priority is repairing my customers' amplifiers. So anything that I own that needs repairing generally gets pushed to the back of the pile. The only reason I brought that one forward was so I could do a cool video for you guys with my friend Ashley repairing it on live stream for you. But now that that's done, and the amplifier needs work, it's gone back to the back of the pile again. Just subbed to this guy recently. Where's Beveridge from? Ah, I'm from the UK. I'm from just outside London in a place called Dartford in Kent. I have a 200 watt Kenwood amp that was connected to a 2 ohm load when only rated at 4 ohms. It's only in protection now. Do you think it's just the FETs? If it's a 200 watt Kenwood, it's probably going to be a class AB most of the time. So it won't be FETs, it will be transistors, because class ABs don't use MOSFETs on the output section, they use transistors. So yes, but it will probably be the same type of issue as FETs. It will be the output transistors will have most likely gone short, and so you'll have to open her up, use your multimeter to confirm which of those have gone short and replace them. And then if it's still getting hot, or if it's like blows again, then it will be that the drivers for those transistors are also damaged. But usually if it's a simple fault like running lower than desired impedance, then most of the time the drivers don't tend to get damaged straight away. So you might have got lucky there, and it's just output transistors that you need to replace. Hello from Corpus Christi, Texas. Yeah, I was in Dallas recently, so not too. I mean, I guess Texas is pretty fucking huge, but like it's closer than the UK, so yeah. How's it going? How you doing? Yeah, John, I did laugh at your comment, and then the next ones. Have you ever repaired an Alpine MRD series amp? Alex, yes, I have. Actually, no. MRD. I'm trying to think back now. I repaired a fair few MRP. I think the MRD are the smaller little ones with a silver front, I think. Not sure. I may have done. Why? Do you have one that needs repairing? And if so, what's the issue? I'll try and help you out. Alright, so yeah, now the inductors are reconnected. Let's see whether the FETs stop getting hot. What the fuck? Something is not connected. There we go. Oh, no, the ground isn't connected. What? Oh, that's better. 1.9 amps. That's lower than it was. I think we were at 2.5 before. That looks much, much better. And they're staying nice and cold now, I think. Yes, so having the inductors out the board was causing them to heat up. So this is, boom, fixed as well. So we fixed 2 Sundown amplifiers in the same night because they weren't broken in the first place. A technician's dream. What a waste of fucking time that was. I just needed to man up with my current supply. Which is really strange. This is a bullshit amplifier design that it needs to suck 20 amps initially to turn on. I've never seen that before. Thanks for the info. I tried changing the trannies out. I had it for years, but I'm just waiting for my experience to grow before trying it. Yeah, cool. I mean, swapping out the transistors, just give it a go. It's a baby little amplifier, so you can run it on a really small power supply from home, and if there are any issues with it, then they will start getting hot and they won't blow, so you'll get plenty of warning before that happens, so give it a go. Alex says, I think it's the MRD M605, the V12 series is another name for them. What's it doing? What's the issue with it? Is it blown output FETs? Oh, so buttons for gain control menu don't work. Oh, it's one of those things. Okay, no, I haven't worked on one of those, but all 3 buttons stopped working at the same time and works fine other than the menu, but I can't change gain settings. Well, that will just generally be a bad solder connection on the riser board or the ribbon cable for the buttons. So I would maybe pull her apart, like, so disconnect from the car, leave it for a couple of hours to let the capacitors drain, take her apart, and you'll notice that there is like either some headers that go off to the buttons, or like a ribbon cable or something like that. I think in those amps they use a ribbon cable. It's a pain in the fucking ass to take apart because it's very fiddly. It's almost like a MacBook or a laptop to take apart. So yeah, take a look at that and like reseat all the connections and then put it back together and see if it works. If it still doesn't work, then you may need to resolder something somewhere. Use your multimeter to follow the continuity of each of the traces to make sure it makes its way from the main board to the button riser board, and whichever trace doesn't have continuity from board to riser, that's the one that's broken. Sam, does Customs still puncture the caps in amps to get sent to the UK? That was only happening on amps coming from Brazil. Banda amplifiers that we ordered from Brazil, the Brazilian Customs were convinced. They were convinced so that there were so many drugs in these amplifiers that they decided that they would drill holes in the case and in the capacitors and in the MOSFETs to see if there were any drugs in there. And then when there weren't any drugs in there, because obviously there wasn't, they just shipped it off to the UK as if it was fine. And just, you know, we got the amps here and we were like, what the fuck, where's there a great big hole in the front of the amplifier? But that's the only occasion that I've ever seen that happen. I've never seen that happen from anywhere else, any other seller, any other company. It's just using eBay to bring amps over to the UK, like Taramps and Banda. But that issue might have stopped now. So hello to Kappa. Unfortunately, we've actually come to the... Well, I'm starting to wrap up the stream now because these amps are good to go. So, unless you guys have got any questions or want to chat about anything, I'm going to call it a night and get some sleep. These amps are huge. Do you also use these huge amps in your whip? This isn't that big. This is a teeny tiny baby amplifier. This is a teeny tiny bicicleta baby amplifier. This is a 1500 watt amplifier. Some of the amps that I use, so one of the amps that I'll be using in the van will most likely be a Banda Viking 10,000, which is a 13,000 watt RMS amplifier. 13,000 watts at 1 ohm. But there are much bigger amplifiers than that available now. Oh yeah, sorry, Rowan. Yeah, the Proton system isn't any further progressed. It's there. It's still in the same state as it was on my last video. Why would you want 13,000 watts? Because competition. Yeah, and because I imagine you're coming from old school times where power was more expensive and you didn't have power on tap like we have these days. So back when like a 1,000 watt amplifier was a big amplifier, you needed to make subwoofers that were very efficient, that made use of the little power that you had available to you to get loud in a competition sense. So you would have like the Soen Vega Stroker style of speaker, and the Emat's Juggernaut was also a very efficient speaker, and those made good use of the power that you had on tap at the time. And Digital Designs were also like, you know, they designed very efficient speakers as well. However, as time has gone on and technology has improved, power has become incredibly cheap and accessible. So in order to get loud, obviously you have all this power now, and so all the woofers started ripping themselves apart, and so the woofers started being built much stronger with heavier, bigger voice coils, thicker cones, tighter spiders, bigger surrounds, etc, etc, which made them far less efficient, but they could take the power and they got louder as a result. So you just have this massive continuous battle between power and power handling woofer, power handling woofer, power handling woofer, and as proven by the world record scores and competition scores, we are getting much louder as the years go on. It's now not that uncommon to have 160 decibel cars that can play 160 decibels from 25 hertz to 60 hertz, for example, using the likes of 30,000 watts RMS and 4 15-inch speakers. That is currently the Proper Droppers world record in Ward Plus, set by Mushy over here in the UK. I think he still holds the record for that. 415s, Sundown NS, I think they were Nightshades. I think they were Nightshades on 2 Digital Design Z2C or Z2B amplifiers, which actually I think is like 24k, but they were wide down to 0.5, I think. So yeah, very loud, and as time goes on we are getting louder, but we need power to do that. And yes, it is massively bad on your ears. It's not good for your ears at all, but hey, humans like power and like winning. Yes, Rowan, I still have plans to do the Infinite Baffle 21-inch DDZ. Yeah, definitely. Brian's got another question. Well, far away, my friend. Orion HCCA any good? They were good back in the day, but they're very inefficient. I'm not a massive fan of them, but they still hold up. They still stand against the test of time. They are still a loud woofer, but they're not musical. They sound a bit shitty. They sound slow and like not responsive and not very musical, and they can't play kick drum frequencies and shit like that. So they suck in that respect. But they still drop balls if you give them decent power. Oh, thanks for the kind words, Alex. No problem at all. I enjoy making these live streams. What's the loudest you've got metered? I have never metered like crazy loud because I've always been selling and fixing and selling and shit. So like all my systems in the past, I built myself. And then I got to the point where the kind of sound system that I wanted in my car was above my own capabilities of fabrication. I'm not a installer or a fabricator. I can install like in the theoretical sense, like, you know, in telling people exactly the right way to wire things up, or the box specifications to make, but I cannot be bothered to get my hands dirty with enclosure fabrication. I've done it before in the past. I used to make enclosures, all sorts of bits and pieces, but it's massively time consuming, and I hated the sawdust, and I hate getting down on my fucking hands and knees and like cable running through places. I hate all that shit. So I tell my acoustician guy what I want, Henry from Howard Acoustics, who is miles better than me at fabrication, and I say to him, this is what I want, this is the kind of sound that I'm after, I want you to wire it up like this, or like, you know, we talk about it together, and that's what we do. So the van was actually a customer's build that I supplied the equipment to, and Henry built, and now I own it. My Proton is something that I wanted done with the transmission line door cards. I've set it up, I've EQ'd it and timelined it exactly how I wanted it. I wanted everything, the pillars to be where they are. I wanted the T-lines on the doors with the certain sound that I wanted, which we've now been able to obtain. It's amazing. But yeah, the loudest that I've ever metered is currently in the van, because the van is is like the loudest vehicle that I've had, because I haven't had a loud vehicle for fucking years. Before that, the loudest vehicle I had was the Proton with the two, I think the loudest system I had in there was the Xeon 15s or the RE-XXXs or something like that. So yeah, since then I haven't had any systems for a long time, but I've now got the van with the 6th order with the 215s, so it's only 215s. It's two Digital Designs 3500 series with a 700 series motor, so it's a weaker motor than the actual 35. So they're pretty entry-level subs. They're not very powerful as such. They sound lovely, but they are pretty entry-level as far as that goes in terms of numbers. And it's only on 4.5K, so it's 4,500 watts. And we have very cheap basic leisure batteries in there and stock alternator. So at the moment I'm metering just over 153 decibels, pretty dead flat as a pancake from 25 Hertz to 40 Hertz. So it's 153 or above from 25 to 40 at the moment, with the 35 broken into how they are, and with the single LW Audio 4500. However, my Digital Design Z series subwoofers, I have just ordered the Z4s, and they are landing in the UK on Thursday, I think. So those will be going straight in, and that will instantly make me louder. I imagine I'll be like 130, 154 or something like that on the same amplifier. And then obviously I'll be able to throw a whole bunch more power at those two Z15s. So I'll be able to upgrade the power supply to twin 350 amp alternators, shove like some lithium batteries in there, some super capacitors in there, and brace up the cabin of the van as well. And I should then be on my way to 158 dBs from 215s. Fingers crossed. I have no idea what scores it will actually do, and it's quite a large van cabin, so I have that going against me, but it is a beautiful build. It's a very efficient build. So I would quite like to see 158s when the system's completely finished, with like the maximum power supply and the maximum power going to the Z's woofers. Yeah, 158s would be really nice to see. But I'm never going to get a 160 with 215s, like at the frequencies that I'm playing. I'd get a 160 all day if I was doing proper SPL, like DB drag, like playing 60 Hertz burps in like the burp box, you know, in a small vehicle. But I'm not. I have a big van with a 6th order that plays from 25 to 70 Hertz, and that's musical as fuck, and it's flat, and that's what I want it for. I want it for hair tricks and music. So it's never going to do 160s, but if it does high 150s, that'll be pretty cool. T-line doors in this bitch. Yeah, man, the T-line doors are absolutely incredible. Uh, 70N06L replacements. I know you like the 3205s. The 3205s are industry standard. They're better than the 70N06, so get the 3205s. 3205s are 110 amp, and the 70N06 is a 70 amp. So get the 3205s, they're much better. And they're super cheap. Super cheap. If 13k is for sub, how much power for mids and highs? Well, you see, mids and highs is what fucks your ears, okay? Your ears are nowhere near as sensitive to low frequencies as they are high frequencies. So on mids and highs, I've got Class AB or Class A Genesis amplifiers that are like 75, 80 watts a channel, and that's more than loud enough. I hate having tweeters and mids screaming at me where it hurts my ears. Bass doesn't hurt your ears in the same way that loud mid-range does. So on the van, I've just got literally single tweeters either side, single 6.5s, kick bass behind the seats, 4 PA 10-inch woofers, and then the subs. So the subs are the thing that needs power, because that's the stuff that gets metered in competition. I could go obviously much louder with mid-range setup, but I don't need to. Like, it's loud as fuck in there as it is, and it sounds amazing because it's on really high quality, high bias Class AB amplifiers. So low power on the mids and highs, nice clarity, SQ. So when I drive around town, like, I ain't slamming full tilt all day long, you know what I mean? I'm actually got the subs down on pretty much minimum, using barely 30 watts probably, clamping to the subs when I'm driving around town, and I'm listening to the setup in a really balanced scenario where the bass isn't overpowering and it sounds proper. But then, you know, when I walk past when I drive past a bunch of dickheads or something, the windows go down and out comes the 4.5k or the 13k, and whoa, suddenly hair tricks are flying and the door's about to fall off, and it's good fun. So I like having the ability to crank the shit out of it and go nuts when I want to, but on a daily listening basis, I keep it balanced and level and SQ-ish, which is, you know, yeah. Have you had any experience with the JL Audio W7s? I actually have a 10 W7 sitting here with a fucked corroded foam. They seem, I haven't actually used one myself, but I've tested them in the workshop, and I've obviously, you know, felt and feel them and done stuff with them, and they seem like really, really well built products. They seem like really fucking cool speakers. So yes, but they are well overpriced, but they're really, really nice speakers. 80 should get you about 800 watts RMS. In the UK, £80 will get you about 1,000 watt RMS in today's market. What would cause high side power to be at speaker output? Power supply side checks out fine. So if you've got your positive rail, like positive DC voltage on your speaker terminals, then you have a shorted output transistor or MOSFET somewhere in the output section. Or you have one of the sides of the amplifiers not being driven. Yeah, you either have a shorted output transistor or MOSFET, or one of the MOSFET sides is not being driven properly, so therefore you have DC from the other one that is being driven. I already changed my plans from the front stage of my theoretical car when I do 2 times Timpani, blah, 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 whatever those are, woofers, in sealed enclosures per door, and 2 times Tectonic 2-inch BMRs. Oh, that would be very nice. Yeah, good choices and stuff. The BMRs are pretty cool stuff. So that should sound lovely. And the sealed enclosures on the doors, mwah, lovely as well. I don't like infinite baffle indoors. I just don't like it. T-line or sealed or ported. So get some enclosure on your door. It blows you away once you get an enclosure on your door. Makes such a difference. I bought a tiny Kicker 200 watt amp. The size of my hand, it gets hot just with no power, to no input. Oh, that's weird. The handheld amps that I've had experience with are the Banda Pocket, the 250.2, and those run cold on idle. So I guess that's a different circuit design going on there. I've asked before but couldn't remember your answer. Why do Alpine Type X power amps more power at 2 ohm than at 1 ohm? So the Alpine amplifiers are designed from scratch in-house by a technician that works for Alpine. So what they've done is they have actually built a regulated power supply and output section, and the thing is that at 2 ohms it'll do a certain amount of power. So let's say the rail voltages are plus minus 100 volts. and at 2 ohms it makes use of that. However, as soon as you wire to 1 ohm, okay, then the current demand from those MOSFETs is going to be much greater. To compensate for the additional current demand, the rail voltages, they lower themselves. That you get voltage drop, deliberate voltage drop, probably controlled voltage drop across the rails to bring the rail voltage down lower, so that the total power dissipated across the FETs is underneath their limits, so they don't explode when you run a 1 ohm. So that's why you get more power at 2 ohms, because the rails probably aren't going to move at 2 ohms, whereas the amplifier is having to compensate for the extra current by lowering the rail voltage to lower the power output across the FETs when you drive a 1 ohm load. I think that's why. Don't quote me on that. I haven't looked at the schematics for those amplifiers, but I believe that that's what they do. You will hate my tops setup running all PA, 5K, RMS in total. Yeah, like I've listened to guys that have like thousands of watts on their PA on their PA tops, and generally it's to play to the outside world. So with my mids and highs, they're loud as fuck in the van, and they do hurt your ears if you crank it right up and they sound clean. But if you tried to play them to the outside world, it would get quiet very quickly. Like you get to the back length of the van, and you'd be like, "Can you turn it up, please?" kind of thing. So I understand the requirement for lots and lots of power when you're literally trying to play to the outside world, a big open space, a field, a car park, something like that. Yeah, I get it. It's cool. But I would not want to sit in a car with an amp that big on my mids and highs. Cool, anyway, this has gone on much longer than I intended, so thank you very much for tuning in, guys, and all your questions. I hope you enjoyed this slightly wasted time amplifier repair video, but we learned something about these Sundown amplifiers. Give it fucking 20 amps when you turn it on and it will all be fine, as long as it doesn't explode. So thanks for tuning in. I'll be doing more amp repair live streams as the week goes on, so click the subscribe button, click the little bell to be notified when I'm next live, and you'll have some fun times with me repairing shit. Take it easy, have a good evening.